Hello, everyone. Welcome to a Datalere webinar. We're really glad to have you today. We have a very interesting topic with some hands-on demos by our president, Carlos Bossy. The topic is how to build an agentic AI application that actually works. So you'll see what goes into building one. So just a little bit about Datalere, which I've joined this year. It provides modern and comprehensive data solutions to both commercial and nonprofit organizations of all sizes, helping clients turn data into their most powerful asset and stay one step ahead of the competition. Just for a little background, Datalere is a full service data consultancy, providing everything from strategy all the way down to data architecture and data engineering. So anything that you need, Datalere can provide from a data and analytics perspective. And here are some of our recent clients. Range, as I just said, commercial, nonprofit, big, small, U.S., mostly North American, some in Europe. Next slide. Wayne Eckerson, yours truly, and Carlos Bossy, CEO and Chief Data Architect at Datalere. Now, with that, it's over to you, Carlos, to begin your presentation.
Thanks a lot, Wayne. As Wayne said, I'm Carlos Bossy. I'm the CEO of Datalere, and been working in this business all my life. Obviously, with AI being a hot topic in the data space lately, there's a lot of talk about AI agents and what to do with them. So it seemed good to have a topic in that area, but try to structure it a little bit differently than most people do, and maybe what you see on the blogs. So I'm gonna cover these areas today. I'm gonna talk about a few use cases for AI agents, and I think that's one of the things I see out there in the literature and sometimes reading industry information or blogs is maybe what are the use cases that we have and how could we use them? But I think it's still a little vague sometimes where what an agent does, how it should work, what kind of things you need to do to develop one, and what's the value there. So we're going to do a little demo, and I'll go back to the demo in a second, but we'll execute things, we'll look at the results, and I'm going to do it in Snowflake Cortex, and let me talk about the demo and what it is, just so you have expectations of what you'll see. After we thought about doing this session and trying to do something live, it ends up being really hard to show uh, something as big as an AI agent in a 45-minute or 60-minute session. And how would you develop it, what you need. So I want to show the core components of it so people get a good idea of where to start and what kind of things they could do, but also what's the foundation you need to start doing this? Because just like a lot of other things, there's a strong foundation that can help you get to where you want to get to. And I also decided to do the demo in Snowflake, and for a few reasons. We've been talking about a lot about Snowflake lately, and a lot about Snowflake and Databricks. One of our more recent webinars got a lot of attention where it talked about using both of them together. But tools like Snowflake, tools like Databricks, they're competing with each other and putting much of the functionality to build AI and build agents into into their platforms. So I think there's value in saying to people, if you already have Snowflake, you can already start doing this, right? You can use this as is. Now, in the long run, is this the way people are going to do it? That's hard to tell. And it's hard to tell ultimately how this will be structured. Is this the kind of thing that will live inside a big data database, a distributed database platform? Is it going to live somewhere else? But for now, because your data's there, and if you use Snowflake already, it's an easy win to start trying to get some of this up and running. One thing I will say also about the demo is it is fake data. So even though I'm going to talk about people buying insurance plans, don't take the output to be anything meaningful because the data's not, it wasn't, it was really just invented, made up, randomized, that kind of thing. So you might see things that don't make a little bit of sense in the data, but that's not really the point of this demo. So.
But Carlos, just to be clear, we are building agentic AI applications for two clients right now, and you could say that this demo was kind of inspired by them, by those use cases.
It is actually that is a good point, Wayne. I should have mentioned is I tried to take some of what we're doing in for those clients and reflect it in this demo. So it's not like I just made it up and there's no good business reason for it. This comes from actually a business scenario to a few business scenarios that we have. There's two clients we're building for. There's two other clients we've proposed it for and are probably going to pull the trigger on doing it. So I think it's a pretty relevant topic today.
Yeah. So yeah, why don't you keep going? I had one question, but I'll hold off on
Okay.
that. I think, we were going to ask the attendees, as we discovered, this was a lot more to stick into one webinar than we thought. And we were looking to get some feedback on whether you, the attendees, wanted to break this up into three or four pieces and allow us to go into more detail. But we'll talk about that at the end.
Okay. Yeah, that'll be good feedback to get for us, I think. And we can certainly do more presentations on topics that are of interest out there. The first thing I wanted to talk about here is what are the components of an AI agent from a data architecture and data engineering point of view? What do I need to have for an agent to actually do its thing? Now, what is an agent doing? I want to show that instead of talk about it, but an agent is basically solving a complex business problem for you. What I want to relate it to is the problems that you and I do on a day-to-day basis, or anybody out in business does. There's a problem out there. This I'm going to show a health insurance model. So one of the problems that often exists is people are enrolled maybe in two health insurance plans simultaneously, and that shouldn't be the case. They should be in one or the other. So I might have an agent, I might have a person go find what the problem is. And so if you kind of think about what an intelligent person would do, they might first go look at a big picture set of data and see, do we have how many people, how many accounts do we have that have more than one health insurance plan? And then from there, they might dive in a little bit more and look at characteristics of each of those accounts. Are there certain people, certain types of accounts involved in that? Maybe it's a certain agent or a broker they use that sold them those plans. Maybe it's younger people, maybe it's older people, but I'm going to try to discover things about the data to try to understand it. And then as I go along that process and I gather more data, I gather more information, I start to formulate a plan, what I might do. And in the end, what I might do is find that there's an issue with a particular agency out there selling health insurance. They're not canceling the plans properly, so we're not seeing the cancellations. So that process is the same thing an agent would do. The agent's supposed to be intelligent, so it's supposed to mimic the intelligence of a business, of somebody who's savvy in business in this area. But it should have the capability to be able to go through that process and do the same thing that I did. Look at a set of data, then further drill down into it and look at it in more detail. Look at the characteristics that make up that set of data. Look at anything else that may relate to it, and ultimately take an action. Maybe the action is determine that one of those health insurance plans is invalid and it gets canceled. Now, in today's world, I could build an AI agent that does all that, and I could ultimately cancel one of the plans. I'm not sure business is ready for that yet. The agent may recommend a cancellation, and then somebody maybe has to approve it. But in the future, we might see that happening. The agent goes all the way and ultimately takes an action that's fairly drastic, but decisive. I'm going to cancel health insurance plan one and keep health insurance plan two for you because I think health insurance plan one is the wrong one. That's one that should have been canceled. So what we're trying to do is mimic those processes that are time intensive, take us a long time. They're difficult, they're complex, and often there's no quick answer to them. That now, what can I do to get an agent to do that? I can give the agent access to everything I have, all the data sets, all the history of data. I can give it access to what's happening in the call center and things like that, ultimately to be able to make the same decisions that a human might make to handle problems like this. So when I talk about an agent and the components, one of the things it needs is a semantic model. The semantic model is a reflection of business abstraction of the data that you have. So I might have a data mart that has financial data. It might have sales data, expense data in it. I can put a semantic model on top of it that describes it in a way that I can use it through natural language or I can use it via an agent. And if you think about an organization, how many of these semantic models they have, you could say there's an organizational semantic model, which there is, but almost nobody uses the organizational model in reality. I might have a departmental financial model. I might have a marketing model. I might have a human resources model, a staffing model, a call center model. And all those models are ways for me to interact with the data that we have stored in either our data lakehouse or data warehouse or somewhere in Snowflake. So the semantic models are really, really important to getting this done because it's what gives the agent visibility into all your data. Just like me as a human, I want that visibility into all the data so I can go from data set to data set and try to understand and make decisions. The other key component is text search, and the reason search is important in this area is because it helps us with that unstructured data. If I'm dealing with a health insurance plan problem, I also want to know what people are saying about it. Are they saying that they're switching plans or they're having a difficult time canceling plans? If that's what they're telling our call center or they're emailing us, that allows me to make a better decision as to what to do to solve this problem. So we want text search. We probably want predictive models somewhere in here. We want to be able to classify data. For example, the example I used of which plan is the more relevant plan to somebody and which one should I cancel. I could have a classification model or predictive model tell me which one it thinks is the right plan. Or I could also have a model that clusters the customers that have a problem together and see if there's anything alike between them. And then custom code that does something like take an action. It actually cancels a plan, or it logs the results, or it produces a report. In this case, what I might want is just a report that says, these 23 customers need to have their plan A canceled and they need to keep plan B. So all these components can be used by the agent to make a strong decision or a strong recommendation as to what to do.
Hey, Carlos, just to clarify on the semantic models, are you describing there the traditional star schema or third normal form schema, or is some kind of schema, or is it more like a business objects universe of old, or something entirely different?
Well, I think what we're defining is all of those, right? It's a way to take the current data structures that you have, and if you have strong data structures, it's a huge advantage. If you have a good star schema, the semantic model describes the star schema. It doesn't have to change it, but it does have to describe it, and I'll show that quickly. If you have the data in third normal form or some other data structure or data modeling methodology, it still can be used that way. I mean, I can still get value out of it. I can have an order line type, scenario and build a semantic layer on top of it and make it useful. But in general, I would say most of this functions better with most of the traditional data modeling we've done for analytics and business intelligence typically. On the other hand, an agent can also maybe have a need for a single transaction. Like I was saying, it might need to cancel a particular insurance plan enrollment for somebody. And so being able to dive into or have that visibility into that data is also important. So that would be typically maybe structured as a third normal form structure, or maybe it's a NoSQL structure, some kind of other structure. But the fact that it can view it and make a decision based on a single transaction is also valuable. So any data model that you have can be, the semantic model can reflect that and describe it and make it useful.
So in this context, the semantic model or an AI agent kind of sits on top of your other models.
It does. In
Okay.
fact, I think the next screen might actually show that a little bit better. In this case, if we have an agent, and here's an example of what, and I call these semantic views on this screen because that's the Snowflake term going forward. They're going to be stored as views in the database, but they are actually semantic models of particular sets of data. So in this case, for example, I have an example of an agent that has the ability to look at six different, semantic views. One of them is a finance data mart. One of them is an HR data mart, or star schemas, let's say. Another one is a customer service data mart. But I also have it look at an activity log, a transaction, a detailed transaction table, and a shopping experience table or set of data. Let's just call it a data set. A table's the wrong way to say it, but it could be multiple tables, multiple sets of data. And by using the semantic views, it's the agent can query into any of these and get an understanding of the situation I'm trying to solve. The next thing I do here is I have a search. I want it to do search on text as well. So I have it searching customer service notes, correspondence that we get, and IVR conversations, or phone conversations that are recorded in text. And by being able to search that text, the agent can also get an understanding of the problems. If these people are regularly calling in and saying, you know what, your website isn't working and I don't know how to cancel my plan, we would be able to maybe understand that from searching the customer service notes or the IVR conversations, or the agent would understand that. We could also involve machine learning. When I'm trying to make a decision about a customer, what is the next step in their journey that we need to apply so that they can ultimately get to the goal of being properly insured. The next step maybe they need help with logging in to the website, or something like that. But the machine learning model can give us a prediction as to what the next thing to do is that will make it most likely for them to be ultimately enrolled. I can also have it tell me, is this somebody I should churn? Is this actually somebody who's not really enrolled in a plan and is going to go away? Or is it somebody that we should try and retain? What's the lifetime value of this customer in the future? Things like that that might help me make decisions as to what to do and how much time to spend on the customer. And then custom code. I can log recommendations by the agent. I can queue a next action. I can write a record that says this is the next thing that needs to happen. I could update data directly. Like I said, I can cancel an insurance plan if that's what the agent decides to do, or I can deliver a report. So there's a lot of things that could be done in this case, but all these tools, so like Wayne, you were talking about earlier, these components. So first of all, there's a lot of data under here, right? There's a data, let's assume there's a Snowflake data lakehouse under here. All these components use that data. And then the agent orchestrates all these components to ultimately get to the right answer. And I know that's been a difficult one for me to represent in a picture, but this is, I think, the way I was trying to represent it. Because I think this is a question that often isn't well answered out there in the literature, is what does an agent do? Well, it can use all these things to orchestrate work and ultimately do something about it. So here's the orchestration part. And like I have here, the agent can use semantic views, then it can go over and search, and it can do machine learning and execute some code and go back and forth. There's no order to this. It can do what it wants first. I would say often, typically, the first thing it's going to do though is call a semantic view to get data and understand it, or a search to understand some of the unstructured data. In Snowflake, the Cortex agents orchestrate data, or they orchestrate across both unstructured and structured data sources. The Cortex analyst is where I can create semantic models. And this is where I can essentially talk to my data. Cortex search enables fuzzy search over the data. So, that's where I can search things like, with search, I can ask a question like, what did most people call us about yesterday? And it will come back to me and say, most people called us because they don't understand what premium they're getting when they choose an insurance plan. It can come up with answers like that. So these are the components in Snowflake that allow me to build what I'm going to build. Now, in my little demo, I didn't build a machine learning model, or I don't have any custom code. I'm just going to have the output come to me. But the output could come to a report. It could come to a file. It could be delivered some other way. But essentially, this is the structure that makes up an agent in this case.
Carlos, is the Cortex search just for unstructured data or is it query structured data too?
It's for primarily for unstructured. It's really used for unstructured data here, and it's
Right.
really for text like language, natural language data
Okay.
here, primarily. Although you could search, for example, the subject line of a ticket or of an email, right? So you could say, yeah, we get 10,000 emails a day. Let's just do a search on the subject line and see what the common threads are there, or things like that.
Cool. Just to remind the audience, if you do have a question or comment, please use the Q&A tab and we'll try to address it.
So I tried to also show how an agent might work using all these components in these next two slides. Here's an agent that wants to solve the customer journey experience. How do we get the customer on their journey with us as a client to the next step? So the example I have here is the customer is in flight and has not enrolled this plan year yet. So, and I didn't say it up there, but let's assume this customer was with us last year, but has not enrolled this year for their health insurance. So the first thing I probably want the agent to do is assess the current customer state. Who are they? Are they employed? Where do they live? What's their age? Let's find out anything we can about the customer. So my customer semantic view allows me to do that. It helps me understand everything I know about the customer. Are they, you know, that might help me understand what they need to do next. For example, in the United States, let's say the customer just turned 65. Well, that customer is not going to be likely buying private health insurance anymore. So I can understand that my next step is not to try to sell them a health insurance plan like I would a younger person. I also want to know what their coverage is or what their coverage was. So I have a semantic view of the insurance coverage historically throughout my organization. And so let's look at insurance coverage and what it looks like. What has it looked like for the customer? What does it look like for people in general like that? Maybe people like that customer. And has that customer contacted us? Do we have a phone call, any sentiment, or anything else we can use from that customer? So maybe the IVR data could be important there. Did the customer call us and was he angry and said he doesn't like our service, or is he confused about what to do? So then the other thing I want to do is gather customer history. I can do that through the insurance coverage, the previous insurance coverage they have, the claims they've made. Claims are very important in determining what kind of health insurance somebody might want. Are they making a lot of claims? Did they make no claims? And did they basically feel maybe they don't need the same level of health insurance coverage? So I'm trying to gather information about the customer state, the customer history, what they bought before, who they are. The customer history could also tell me that they moved or they live in a different location. Their doctor has changed. Then I want to see how they've interacted with us. And they might interact with us through the call center and metrics we have. They might interact us through a contact semantic view that we have that has all the contact information that we maintain in a data mart, let's say. And then again through the CRM, maybe through phone calls. And then the next thing I want to do is predict the next step and store the action. So I'm going to take the customer data, the insurance coverage data, call my predictive model that tells me what the next best step to do for them. I'm going to store the results of that model, and then I'm going to produce a report that says, here are all the customers that haven't insured with us again, need to insure, but we need to call them to help them pick a plan because they're confused about the plan. So that's one example of an agent. Here's another example, similar business model, but now I want to know how our operations are going to be affected because we're reaching out to these people to get covered. So that's going to increase the number of people we have covered. And so now I'm reaching out to people from the prior year. And all the things that I talked about now are visible to this agent, maybe a few different ones. I don't know if all these are the same. I think I put up there, but they probably are. But now the actions that the agent is taking are a little bit different. First, it's identifying uninsured customers. Then it's creating a customer profile. Then it's looking at the staffing and call center impacts of coverage. then it's classifying customers, and then it's producing a report and storing the actions that we have. So in this case, what I'm really trying to do is have the system tell me, because of this campaign to get more people covered, what's that going to do to our call center and our staffing, and how do we need to respond to it? And so really frame this as a report to somebody who can do something about that. But it could be that it enters a ticket and it says, oh, you need to schedule 3 more call center people because, it could do a lot of things like that. The agent could actually take action to make sure we're staffed properly.
So, Carlos, we got a few questions here. One person is trying to wrap their mind around what exactly an agent is. Is it a predictive model? Is it a computer program? It sounds like it's just kind of a use case of an use case for this Cortex application, right?
Yeah, it is. I would say an agent mimics the solving of a business problem by using all the data we have at our disposal in the organization in different ways, right? And so the fact that I have data marts at my disposal, I have transactional data, I have unstructured data. The agent, just like I would, uses all those to ultimately come up with a solution. And maybe if the person asking the question sees the questions and then the solution, they'll see I'll show how the agent goes through the process of using all that.
But you'd configure an agent to handle a specific use case, and that
Right,
agent really only does that use case. If you want to do
right.
something else, and you've presented two use cases.
Yeah, like here's a use case. I mean, these are two example use cases here. But like the journey one, the second one here is I want to know why our customers are stuck in getting through their process of selecting and finalizing an insurance plan. What's the next best step? That's a use case. The first use case is the one I'll show an example of. I'm interested in customers who are enrolled in 2024 but not 2025. What are the demographics of these customers? What did these customers say to the call center? If we were able to get 10% of these customers to enroll again, what would it do to our call center resources? So I'm actually solving multiple problems with this agent. I'm understanding who those customers are that we're not getting back. I'm understanding their mood and the problems they're talking about, maybe their sentiment, but also what are the issues they're talking about. And what it will do to us if we run a campaign to get these customers back or some of these customers back, what will it do to us operationally? So I'm actually solving a very complex problem, trying to solve it with this set of questions.
So you kind of have to know the problem you want to solve to pick the right agent to
Of
do
course,
the
yeah.
work,
The use
right?
case,
Okay.
I would say if you really want to get into agent development, nail down the use case first, right? See what are the use cases that you're really struggling with and go there first.
And then a follow-on was how long would such an agent or agentic app take to build?
Well, again, that's a tough question because if you have no foundation, it might take a while. If I don't have my data in a good data lakehouse type of scenario, if I have no semantic models, if I have no custom search engines, those are all, and no predictive models and things like that, those are all time consuming to build in and of themselves, right? So the more I have, the better it gets. If I have a really good data mart like star schema, well modeled, dependable, I can put a semantic layer on top of that fairly easily. But then that only gives me visibility into that data mart, right? So now I need to give it visibility into other things too. And so the better foundation I have altogether, the easier it is to build. It's not easy even with a good foundation. But if I have no foundation, I need to start building the data structures first and the data relationships, then semantic layers on top of that, then the agent on top of that. So,
This is like the revenge of the data warehouse.
yeah.
It's like, we were building all these structures for a good reason, and
Yeah.
now it's here.
Yeah. But in the end, I hopefully can get it to do things that we humans struggle with. In the process, it can look at so much data that it can come up with a good answer for things. And humans struggle with that, right? We can look at 2 or 3 or 4 data points and then everything else is a blur. It can look at millions of data points and make decisions based on that. So that's really what we're trying to do is trying to get the advantages of what it can do and get it to solve some problems a little bit better than we can today, or some that are either unsolvable today or they're very time consuming. So if there's no other questions, what I'll do is I'll go over to Cortex. And here's an example of a semantic view. And this is, again, a little bit of a fake star schema demo of building a semantic view. But, as I start to build it out, what I'm doing is I'm pointing the semantic view at the database data that I have. In this case, I have a star schema in Snowflake. It has a date dimension. It has an employee dimension and so on. So I start to describe it here. Now, what I did here is I didn't build these descriptions. Those were the automatically generated ones, which are good, kind of good to start with. But for your business, you're going to want them to be much more specific to your
So
business.
Cortex generated those descriptions?
It did, yeah,
Yeah,
it
okay.
did. This is a pretty good one right here, dim employee. It's really what the employee dimension that I showed it does. Now this is really being stored in YAML format in a file like this, and it can be edited like this as well. But I'm showing the UI in this case because what I'm trying to do is I'm trying to define everything I might need, just like a human might need. For example, not only do I need dimensions, but I need time dimensions. I need facts. I need filters. I need metrics. Every table might have some of those. I also need to have metrics that are derived among the various tables. I also need relationships. Um, I need to know that the fact table is related to the dim employee table. And if it didn't derive that automatically, I need to create that relationship here so it knows those two can come together. And then I also have verified queries, which is a way of training it to use the data. I can tell it this query is a valid query because I think it's the same query I would have written and it produces the right data. So creating a semantic model of just one star schema would involve this type of work. And ultimately ends up being something like this, where I have multiple semantic views. In this case, I have staffing measures, call center metrics, claims data, coverage, and customer data, which I created all of those views. And essentially, what it might look like is something like this ultimately. Like here's the coverage analysis semantic view. It has 153 dimensions, 11 time dimensions. It also has, a time dimension is the coverage end date, the coverage start date. I told it what the coverage end date is. I tell it what the coverage start date is. I also describe it. I tell it what the table has. I also give it custom instructions. I can tell it what kind of questions not to answer if I want people not to ask. There's certainly certain questions I don't want them to ask. But I can also tell it how to generate the SQL, give it instructions for that. I want to show 2 decimal points for a ratio. I want to show percentages in this format. If somebody asks a question and they don't talk about a plan year, I want to assume it's the current plan year. Um, so then what I do is I ultimately end up building building relationships and then showing custom queries that I've approved that train it to query the model properly. So when we have all this data, um, all this, I now built a semantic view on top of a set of data that now I can use and I can test here. And for the agent, it's only one component in all the components that I showed, right? All I have here now is an ability for it to look at how the insurance coverage of people, but it doesn't show the call center data. It doesn't show anything else. That's then a different semantic view elsewhere here, right? So for example, if I want to see the call center metrics, I would look at this. I gave it a semantic view to look at the call center metrics. And you see here that I describe what it is. This is very small. I created a very small data set for this. It has 4 facts: average call time, average wait time. I guess I have average call time twice, once in minutes, once in seconds, and percentage of calls answered, right? But I'm telling it what it is, how to use it, and so on and so on. So that's what I mean by building those semantic views. The search is kind of similar. I create a search And again, don't want to go into details here, a lot of details, but what I did, I created a search over the call center data. And what I'm searching here is the subject line. And so what I wanted to do is build a model that says, if I ask it questions of the search, it'll tell me what people are calling about, or it'll tell me what the top three problems we have are, because it's analyzing the subject area of the call. And then I'm going to put it together. And so I don't want to run out of time here. So I'm going to go to the agent itself. And just to show you that I've run the agent already, but I've got output here on the right, and I'll go back to that in a second. But what I'm doing here is I'm looking at the agent, and I came into it here in edit mode using the UI. So you see what the various things I have to do here is I have to describe the agent. What am I going to do? This agent assesses the impact of company operations of marketing to uninsured customers. I have sample questions that people might ask of the agent. I have the tools the agent can use. This is the key, right? The agent uses these semantic views: call center activity, claims semantic view, coverage semantic view, customer semantic view, and staff. It uses all those views to understand the data. It also uses the search that I created that for calls, and it analyzes the subject line of the call that we got, or of the contact from the customer. So in this case, I have 6 different components that it's using to make decisions about what I'm going to ask it. So I'm going to ask it questions like this, and let me hop over to because this sometimes can take a little bit of time to run. I had some results here beforehand, but let me show you the kind of questions I want to ask it like this. I think I showed this in the example earlier. I'm interested in customers who are enrolled, but not last year, but not this year. What are the demographics? What did these customers say? And what will it impact us? How will it impact us if we get some of these customers back? So what I'm going to run this, while I run this, now in this case, the result is just going to be essentially a report back to me. The system will not do anything automatically. Like I said, though, I could have the system take action. I could have the system staff more people if we need more people, and interact that way. I'm going to run it, but I'm going to show this question I asked previously that I had here. I asked it, I want to ensure that our health insurance helps veterans. Oops, sorry about that. It's moving along. And I want it to tell them, I'm sorry, it's interacting with me. So I want it to help me understand how veterans are enrolled with our health insurance, right? And essentially the system came back and told me, you don't have any veterans enrolled and you've never had any. And in a way, it probably makes sense. It either makes sense one of 2 ways. We don't capture that information, and maybe we don't, or military veterans get their insurance through the Veterans Administration, at least in the United States. So they would not enroll in private insurance typically. So, but it gave me back that answer, and it actually did an analysis of veterans and why they're not enrolled in our system, and so on and so on. So even a question like that, what it told me to do as a next step is right here. As I scroll up a little bit, implement veteran status tracking so you can analyze their patterns, right? Now, this one that I just asked it, it's going through the process, right? And so what I want to do is skip over to the result, because I'll go back to here in a second and show you that it gave me a result. But this is what it did. It did all these steps. It said, first, I'm going to think. And it says, here's the next steps I want to take. I'm going to repeat the question back to you. You asked me a multi-part question about customers. You want the demographics of these customers. You want to know what they said to the call center. You want to know what the impact is on call center resources. So it says, let me break this down. I need to identify customers enrolled in 2024, but not 2025. I'm going to use the coverage tool, the coverage semantic model. I then going to analyze their demographics. I'm going to see what their conversations were, and I'm going to analyze call center capacity. So it's doing all that as we're speaking. So first it identifies a customer. So what it does is write this query to get customer data back. So you see the query that it writes, it executes it. It comes back and tells me Now I need to plan the next steps because I have some results. I found that 41,916 accounts were enrolled in 2024, but not 2025. 75% of the accounts. I need to get the demographics of these customers. So it writes another query to get demographics. It comes back, and of course, I've defined it in the semantic view what the demographics of customers are. It says, I have demographic data showing 125,000 churned customers at the person level, not the account level. Let me search for what these customers said to the call center. So it tells me, it does that. And it says the search results show that most people called because they were enrolling in a new plan. That's the most common subject matter in the call. So now it goes to the next steps. It also says I get call subjects about estimating out-of-pocket costs. That's a big topic. And it also says it's seeing a subject of explaining plan options or differences as an issue, right? So it comes back with three different things that people are saying to us. Now the next steps. So it says I'm gonna look at call center activity. It says my call center activity doesn't have call volume data, which I didn't give it that, but it's gonna check the staff tool to see what, because there's where I track the number of calls each staff handles. So it writes a query for that. So you see now this is the third query it's written in the steps. Now it says I have call volume data. Let me get your call center performance. It writes another query to get that. Now it says I'm going to plan the next steps. I've got 41,000 accounts that didn't enroll. 10% of those is 4,192. I'm going to estimate how many calls this would generate to your call center. It says I have enough information to provide the answer. I have demographic data, call center data. I have the impact calculation, and so on. And it shows you its calculations. It says if we assume each re-enrolling account generates calls similar to the average, I need to estimate the call volume increase. And it turns out we're going to get 4,105 additional calls per month. It also says that I would need 14 additional customer service employees, ultimately down here, to handle those calls. So because I gave it visibility into so much data, it can give me so much of a result in this case. So basically, it's telling me that I need per month 4,198 calls or 105 calls. That divides it by 298. That's how many calls an employee can take per month. That would require 14 people to do it, to schedule. So that's really what I wanted. What's the impact to my call center? Now it's going to give me the demographics, just give me overview information of about what I asked. The demographics are the people who did not re-enroll. This is their age distribution. This is the gender distribution, their employment, the average size of their household, their ethnicity, the call center topics that they're calling about, the impact of re-enrollment, and so on, right? It gives me a full summary, a full report. It also tells me that I currently average 213 customer service employees. And in the end, the recommendation is add 14 customer service reps to handle the re-enrollment campaign. That's an agent. Now, I don't know if that's a lot or a little for this short session here, but it's a lot, right? Now let's show it on this side. I'm showing you here that it actually ran it while we were talking. And you see that it even gave me a little bit of a different result because I showed it now different data. Since I captured the output of the previous result, I've changed the data, I've changed the models a little bit. And now it's going through but doing the same thing. I'm analyzing the data. I'm figuring out what their income is and what their ethnicity is and other things like that. I'm establishing your call center information. And ultimately, it gives me the recommendations. And here it gave me more detailed recommendations. It's saying hire temporary staff, which may be a reach. It said contact these customers before enrollment season to spread call volume out. And so on and so on, right? But it also says, you have a group of people who left because they didn't pay their premiums. So it says focus on that as well because that's a big chunk of people. So that shows you that as I was talking through the other result, the questions that I asked here were being answered. And if I show all the details, you'll see that it shows me all the things it's doing. The SQL that executes to do its thing. There's the second SQL, the third SQL, the fourth SQL, the fifth, and so on, ultimately to get to the result. Again, that's a lot, probably a lot for one session because now people are, might be wondering, well, geez, I need to know about one semantic model, and now you're showing it with six semantic models and search engines and all that. But that's what an agent is. An agent has access, it has everything at its disposal, everything in an organization that it can access to go through this process and make decisions for you.
So where in the screen here that you're showing is the agent that you just ran? Is there like a list of these agents somewhere?
Yeah, the list of the agents was back here, I believe. Let's see, I had it. Maybe I need to go backwards one here. It's here. Oh, I'm sorry. This is the semantic views, the agents. If I go down to here I have two agents in this particular database schema. The one I just showed for insurance coverage, and then another agent to demo customer journey. There. So these are the agents. If I open up the agent, you'll see that then I can look at the agent, I can edit the agent and make changes to it.
So these are pretty powerful. What if you're asking a question that's kind of a little bit outside the boundary of what you configured it for? Is it able to adapt or probably not, right?
There's few ways, right? I should be able to tell the agent here what kind of questions to answer and what kind of questions not to answer, right?
Oh, hmm.
Um, like in this case, for example, and by the way, I didn't mention this because people wonder about the LLM behind this. In Snowflake, we have multiple LLMs that we can choose. You see here that in this particular case, I used Claude Sonnet 4.5. And by the way, the one I showed in the Word document, I used GPT-5. So another reason for me getting a little bit different results and a little bit different way of speaking to me because of the different LLM I used. But in this case, because I use Claude Sonnet 4.5, that's the result I got that when I hit the button here, that's the one. The
Hmm.
result I got here was because of Claude Sonnet 4.5. In this case, right, I'm telling the agent how to reason through these tasks. Now, again, it's a demo. I give it very few instructions, really. I can give it a lot more detailed instructions here. I'm telling it what I would do if I was going to solve this problem, right? Essentially. I'm also telling it how I want it to respond to me. I want the agent to provide analysis about the impact to our operations, call center, and staffing. Right? And I'm also telling it how long it can run. I didn't give it a limit here. But if I don't want this agent to run for hours, I can put a limit on it. It'll give me a result, right? Or same thing with tokens. If I don't want to spend that much money or an unlimited amount of money, I can put a limit on it there. But essentially, what I'm telling the agent what to do, how to do it. In a real scenario, I would do it probably in a much more detailed way. And um, and then the other thing I'm doing here is I'm also telling it. I think it was back here where I showed this, where I can tell it what kind of questions I don't want this to answer, right? So let's say somebody asked me to tell it um, what's a specific social security number of an individual. That may be a question that I don't even want it to try to answer, even though social security number is not in the data. I don't want that type of question to be answered. So I would tell it, don't answer any personal information about people. We can put people into groups, right? We can put them into age groups. We can put them into categories, income categories, things like that. But I don't want somebody asking what's somebody's income, for example. And the truth is, I wouldn't make income by itself available in this model if that was a problem. But I also maybe don't want it to answer questions that are out of bounds, like who's going to win the Super Bowl this year, right? Or so, it might try, right?
Okay, fair
Okay.
enough.
So essentially, what I can do then now is I can use my agent, and I'm in a development environment here, right? This isn't the way it's going to look to a user or business user. The user is going to see a report or an action or something, but I can ask it anything here. I could say, I could just say, something along the lines of did people not re-enroll because of higher premiums? Or I could say because they didn't make any claims, right? Or things like that. Now, maybe the model's not really set up to answer some of these questions, but it could give me insight into what's going on. So the agent tries to tackle the problem, right? And it tells me how it's going to tackle it. And so the agent, once I set up one agent, I can use it in many different ways. But like we said, I mean, and we're big on preaching to people that a strong foundation is really important to do any business intelligence, any reporting, any analytics, any machine learning. And it's very clear when you're building AI and building agents that a strong data foundation is really important to make progress there as well. If you have a very scattered data foundation, you're going to have a difficult time having AI be intelligent about what it does as well.
So let me ask the audience at this point, if that's okay, Carlos, whether they found this helpful or would they want us to spend more time on specific parts of what Carlos went through today. If you have any thoughts about what you saw or would like to see if we do this again in another method or approach, let us know. We'd be very appreciative of that. So the model is still, the agent's still running, obviously.
It's running, and again, because it's demo data, there's not a huge amount of data here. Again, if you had billions of rows of data, queries would take longer, that sort of thing. Um, but I'm running it in Sonnet, and Sonnet likes to give you back answers like, great, perfect, this is really good, right? And it's I think GPT-5 sounds a little drier and more business oriented. It even show me a couple of charts and graphs there, right? That I could put in a report.
Nice.
And then it tells me what to do, right? It told me what it found. Those who did re-enroll face an average increase of $31.52 a month. And they said customers who didn't re-enroll were facing higher premiums, right? Which is true. So it tells me what it thinks I could do about those people. Or so that's essentially it. And like I said, this is a big topic. I wasn't sure we could get it done in an hour, and I'm not sure we did, but it'll be good to get feedback from people and see what they think.
Great. Well, I think with that, Carlos, thank you so much for taking us through definition of what an agent is and showing us what it looks like and how do you build one.
Thanks a lot, Wayne.